All right, so in this learning objective and the next one, we're going to look at one of the most important applications of functions, and that's talking about average rate of change. All right, so one of the most important concepts in calculus, something that you probably spend 60% of calculus, all talks about how a function changes and how real life situations change. So change is a really important part of calculus. All right, so in this learning objective, we're going to kind of introduce the foundation of this calculus concept at the basic level. All right, so what do we mean by average rate of change? Well, when you go on a run, you're not running at a steady pace. Maybe at one point you're running downhill, so you're running a little bit faster, and then at the bottom of that you come to a hill and you have to slow down because you're going uphill. So the speed you're running, you might be fast for a bit, and then you might slow down, and then you might go fast for a bit, and then slow down, and maybe like you level off towards the end, and then at the end you kick, so you go really fast, or something like that. So this was the speed you're running. It's not constant. But at the end of your run, maybe you ran 2 miles in 18 minutes. Well, that means on average, you were running 9 miles a mile every 9 minutes. So even though you don't know exactly how fast you're running at every single second, at the end of your run, you can figure out the kind of steady pace that would have got you to the same place. So instead of doing all these ups and downs, if you just ran at this exact steady pace the whole time, you would end up in the exact same place. But that's not how anybody runs. No one runs at exact pace the whole time. Even professional runners, they run a faster mile kind of in the middle and then a slower mile at the end and another fast mile at the end or something like that. All right, so no one runs steady, but you can talk about if I ran this exact pace the whole time, that's my average. All right, so now we're going to use that idea with our functions, and we have a formula for average rate of change. All right, so we're looking about the average rate of change of our function. How much is our function changing on average from point A to B? This is my function. So my function value at B, so when I plug B into my function, minus when I plug A into my function, all over the x values, that's the B, and that's the A. All right, so this is the formula. There's kind of one formula you have to memorize, but we'll see in a second. It's not like a new formula. There's another way to help you memorize it. All right, but for this first one, we're just going to use that exact formula. All right, if we want to find the average rate of change of this function from -2 to 1, our average rate of change formula, average rate of change, is f of b minus f of a over b minus a. All right, remember b and a are our x values that we're using, so we're going to call this b because that's our second x value, and this a, that's our first x value. So this first step of this formula is just put 1 here and a -2 here. And b minus a is 1 minus -2. So the first big step of average rate of change, after I've kind of plugged in the numbers I care about, is to figure out what is f of 1. And this was on our previous learning objectives. So if I'm looking at a graph, f of 1 means my x value is 1, and I figure out what y value goes with that. So with that x value, I get the y value -3. So instead of f of 1 there, I'm going to have -3. Right. Then I'm going to do the same thing for -2. I go to -2, and the y value there is 0. And then I can do order of operations, subtraction. The bottom, that double negative, turns into addition. And simplifying, I get -1. All right, here's where the kind of simplified version of the average rate of change is going to come in. What am I doing? I'm finding the change from the -2 point, which is this green point, to the the positive 1 point, which is this red point there. And if you look at the formula, I'm using the y value at 1, the y value at -2, that's on the top. All right, so these are my y values. On the bottom, I'm using my x values. We have another formula that uses x and y values, so it looks like this. And real quick, see if you remember what that formula is representing. And the thing that formula represents is the slope of a line. All right, when I take the difference in two y values over the difference in the x values. And that's because what's really happening when you're finding the average rate of change, really, you're just finding the slope that connects those 2 points. All right, so the slope of that line should be -1, and we can see it is because you go down 1 over 1, down 1 over 1, down 1 over 1. All right, so this is a way that you can remember the average rate of change formula without thinking about it as a completely new formula out of left field. Really, it's just the slope formula rewritten in a function notation format. All right, so let's say I wanted to find the average rate of change from x equals -1 to 1. Well, -1 is that point. So at x equals -1, I'm at that point. At x equals +1, I'm at that point. And again, I could go through the entire average rate of change formula, but I could also remember average rate of change is just the slope that connects these points. So to get between these points, I have to go down 1, 2, 3, 4, 5, 6. So my slope, the rise is -6, the run 1, 2, and the run is 2. I simplify that fraction, I get -3. All right, so when you have a graph and you're doing average rate of change, it's important to remember that connection between slope and average rate of change because it saves yourself a lot of time. All right, so here's one to try on your own. I find the average rate of change of this function from -3 to 2. And here's the answer I got. So I actually went through and did the whole average rate of change formula. So I figured out the y values and did it over the x values. But again, we have these 2 points on my graph, and to get between them, I have to go up 4, which causes the 4 on the top, and right 1, 2, 3, 4, 5, which causes the 5 on the bottom. All right, so 4 over 5, or 4/5, is the average rate of change of this function from -3 to 2. All right, so the correlation between the slope formula and the average rate of change formula is really useful when you're doing a graph. It's also useful to kind of help you remember when you're doing a function. All right, but still kind of remembering that the average rate of change formula is the slope formula. All right, we can help us remember that average rate of change is the y values minus the x values. The x values are given to us. We're told that our x value is 3 and 1. So we just need to figure out what y values go there. Well, to figure out the y value that goes with an x value, you just plug that x value into your function. So I plug 1 into my function, I get 2, which means my x value is 1, my y value is 2. So that means I can put a 2 in that second part of the top. And I can do the same thing with 3. All right, when my x value is 3, what y value goes along with it? Well, I just plug 3 into my function. And I get 10. It tells me I'm going to put a 10 there. So really I'm just using kind of the slope formula to my advantage, knowing that the y values go on the top and the x values go on the bottom. And I'm also at the same time using this relationship that x is the input for my function, y is the output. So if I input the x value I care about, the thing I get out is the y value I care about. And after this, it's just simplifying. So 10 minus 2 is 8. 3 minus 1 is 2. And I get 4. So the average rate of change of this function is 4. Our average rate of change from 1 to 3. So it's important to know what's happening. All right, from 1 to 3 is 4. All right, do another example. F of x equals 3x plus 1. Again, my average rate of change is me the y values over the x values. So on the bottom, I'm going to have 5 minus -3. On the top, I need to figure out what my function values are. So my function value at -3. And it's helpful for me because I have different colors, but you can also make it obvious when you're doing stuff that's kind of side work, is to one side you can even like put it in a box to make it separate. This is -9 plus 1 is -8, so that's going to go here. And I got to plug in a 5 as well. And I get 16. So I'm going to put a 16 here. So if I was doing this all in a single color, maybe I would like put a box around this. That way it's kind of shows that it's separate from the actual average rate of change formula, but it's stuff that's actually going into that. But now I can simplify. 16 plus 8 is 24. 5 plus 3 is 8, and 24 divided by 8 is 3. The average rate of change here is 3. And this one's actually kind of interesting because 3x plus 1 is a line. So if you think about the relationship between lines and slope, you might figure out why this answer had to be 3 the whole time. Right, that's something you can try to figure out on your own. But here's one to try on your own. I find the average rate of change of this function from -1 to 2.